Hello, hello, hello. Hi. Lip smack. Anyway, hi. Welcome to Treehouse stuff. Here we go. Music. Alright, so this is a sort of a borderline experimental stream. Namely because isn't that TTS way too quiet again? What happened here? What is going on? This is sort of experimental.
9,999.
Quiet, isn't it? It's experimental because what I'm going to do might not work well at all for a stream. I have no idea if it's practical or not.
999.
Namely, I'm going to look at, or research rather, different rendering techniques and things like that, like how geometry is actually drawn so that it looks, you know, realistic, so it has lighting properties and all of that. So I'll mostly be browsing around the net and I'll be reading a bunch of stuff. And I guess if you have anything to chime in about that, if you know things or if you're curious about things, we can chat about that. I shall link the things that I'm looking at as I'm looking at them, I guess. Why isn't this scaling? There we go. This is... Whoa, 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 whoa. Why do websites like fucking take 3 years to descale nowadays? Does that work? No, for some reason. What the fuck happened? Can I, like, actually see the post? What is this? It somehow... click on the thing, there we go. That should be readable, I think. So, the first thing to look at is... Well, okay, I guess I'll introduce things for people that have no idea. First things first, I guess. So, the way things are usually done is that you represent the stuff you see in the form of vertex-based geometry. So you have a list of triangles made up of vertices, and then you tell the GPU, okay, draw me these triangles, and then it goes around and does a bunch of calculations and fills in these triangles in an image somewhere, probably on the screen. Now, that's only one way to do things. There's many different ways of doing stuff. Like, for example, you can do things with distance fields and volumetrics and all of those kinds of things. They're all different kinds of mathematical models. But this geometry triangle-based approach is what GPUs, modern GPUs are made for. That's what they're good at. That's what they're fast with. So that's kind of the approach you're going to take. It's also the approach that's actually most sensible for most, but not all, things you want to do. So when you draw these triangles, what you do is that instead of, you know, just drawing a fixed color for each pixel, you make some kind of computation to figure out what kind of color that pixel in that triangle should be, so that it looks like something realistic, something that reacts to light, reflects, refracts, bounces, and all of those kinds of things. So there's a lot of physics and math involved to calculate these colors for the triangles. And then there's sort of different kinds of schools about, or different kinds of techniques about how you actually do these computations. Primarily there's two different things, which is either forward rendering or deferred rendering. Now, forward rendering is, in its most basic thing, just how you would do it straight up, like the simplest kind of thing you can think of. So in your vertex stage, you have your normals and your vertices, and then you compute some stuff about each vertex, like information about the vertex at that point. And then in the fragment stage, where you actually compute the pixels, you look up the information that you got computed in the vertex stage, and based on that, you do your physics calculations and stuff. Now, that's all fine and good, but the problem becomes that if you have a lot of lights and a lot of objects and a lot of things in your scene, then doing this lighting computation for each fragment in the scene can become extremely expensive. So deferred rendering takes a different approach in the sense that it you render all the information from the vertices into different textures, and then you do one pass on all these textures and actually perform the shading for each pixel instead. That way you only need to calculate like the amount of resolution you have shading steps and have everything else already hacked into textures and stuff. So you don't need to do it for each fragment, and that sort of saves on things. Now there's different kinds of forward rendering. There's like tiled forward, cluster forward, forward plus 2.5, forward 3, and I have no idea what any of these are, but we're gonna find out now. So I guess we're gonna read through this now. Right. So forward works with multi-sampling, anti-aliasing, which means that basically what you do with that is that for each pixel you want to draw, you don't just take one sample, you take multiple samples on a subpixel level. And then you sort of take the average of that. And what happens with that is that you achieve anti-aliasing because you draw essentially at a higher resolution than what you would normally. And then you sort of, well, no, that's not right. Well, you know, because you don't just take one sample, but multiple ones, when you have an edge, some of these samples are going to land inside of the geometry and some of them are going to land outside, which means that if you average them together, you're going to get a gray value rather than a hard edge. So that's multi-sampling anti-aliasing. Obviously, it's a very expensive technique because it means if you have an 8 times MSAA, it means you need to, for each pixel, you need to draw the scene 8 times. So it goes up pretty fast in terms of cost. But it is the only proper, in quotes, way of doing anti-aliasing. There's other techniques that do sort of post-passes by trying to do edge detection and then smoothing and stuff, which are much faster, but the results can look pretty shitty at times. Anyway, that's that. Right, forward works with transparency, deferred does not. So if you want transparency and deferred rendering, what you need to do is sort of first render all the solid objects using deferred, and then add a forward pass that only draws the transparent objects that aren't blocked by anything else. So you need to combine techniques for that. BRDFs, I don't know what that is. Bidirectional reflectance distribution function. Okay. Whatever that means. Function for real variables that finds how light is reflected on a pig's surface. It is employed both. Okay. What's bidirectional about this? I guess that you have the light and the camera vector? I'm not sure. A lot of this stuff is going to be over my head, so I don't know what that is, and probably a lot of these topics could be entire weeks of research in their own right. But I just want to sort of get an idea of things. And essentially, hopefully by the end of this, I'm going to reach a conclusion where I know which technique I want to implement in trial as a sort of a standard renderer, I guess. But yeah. Okay, forward requires a Z pre-pass. Probably means ordering things in depth or something. This is quite up problems. Oh, you require computators. Oh boy. Alright, interesting. Where's the deferred? Yes, that's another thing I have open. Oh, it has an explanation of that? Okay. Right. I quickly sort of went through this and I know most things that it talks about, but probably not in the same detail. Oh, here we go. ERDF. Let me make this a bit bigger. Function describes the reflectance properties of the surface. Okay. I see. I see. Right. So yeah, if you want to do computer graphics, you kind of can't be afraid of math, unfortunately. Math. If you are, then oh boy. Get more into it. The PBR paper from the Frostbite Energy is a decent sort. Okay.
Mathematics.
Math. Right. Kind of funny. Works on really old hardware, including mobile, but then they say like consumes a lot of bandwidth. Because older hardware, and I assume especially mobile, is probably not very good with bandwidth. Lucky if you get those mobile extensions on chip memory to work in chip device without running your own. Oh boy. Everything gets smashed into one big pixel shader. Right. By the way, Baggers, I remember that you implemented your own rendering stuff, or at least started at some point. What did you end up choosing for technique? Okay, so essentially what it's saying here is that, like, because deferred rendering does everything in a single pass, your shader is going to end up doing a huge number of things at once, which can be bad for GPU performance.
I'm going to read on compute shaders as I don't know those.
Compute shaders are basically just like OpenCL in that you just run code that doesn't do any... Like, it doesn't need a rendering target, as I understand it, so you don't... You can just use it to compute stuff on the GPU, and that's it. Without having to do a rendering context. It basically eliminates some of the rendering stages that you usually have.
Oh, that's useful.
It is, but as mentioned, it's like only available in rather new APIs, so I think... When was it introduced in OpenGL? Core in 4.3 or 4.6? I don't know what that means. So that's fairly recent, I guess. Wrong link. Okay, so when is that? Green space ambient occlusion. Ambient. Efficiently approximating the ambient occlusion effect in real time. Right tech. Interesting. Great. Yeah. So, ambient occlusion is basically used if you have ambient light, which isn't always the case, but usually. So, ambient light is light that is basically, well, ambient. It's basically everywhere. So something like the sun would be modeled as ambient light because the light source is too far away and too large to model as a point source or a spotlight. So that's what you would do with ambient light. Anyway, let's go back. Def buffer. Right, so you don't have the def buffer. Right. Okay. So basically what this means is because you need the depth information to do the ambient occlusion computation, which you need for the pixel information, you need to do all the geometry computations twice. First to get a depth buffer that is valid for the current frame, and then to do it again for when you do the actual color output. Okay. And for deferred you don't have that problem because you already solved. Well, you already have the depth information from your first pass, which is a much faster pass. It only needs to do the vertex and like primitive pixel operations, fragment operations. Main space reflection. That content. Does Wikipedia not have a fucking thing on that? But I'm guessing this refers to actually reflecting things in the scene rather than doing a fucking fake with the cube map. Right. Yeah, okay. Like if you just use a skybox, basically, you can make things reflective pretty easily using a cheat. By just, you know, looking at casting a ray towards the skybox and looking up the color there. And the ray is just a reflection based on the incoming camera ray, so that's how you do that. But obviously that doesn't like, since you can't do ray tracing within your GPU stuff, you can't actually figure out whether there's anything else in the scene that you would have to be reflecting instead. So what you can do is, like, you can... There's a way out of this, which is you can do... for each reflective object, you can sort of render the cube map of what that object sees, basically, around it. Which is weird, but, you know, basically, since the reflection just shows what that point, sort of, that object at the point sees or whatever, you can do that kind of computation, and it's sort of a really ugly fake, but it works for a lot of cases well enough. And I'm assuming that screen space reflections is the more proper reflection idea. You need to know how the shader result is going to look. You need depth, normals from G buffer to compute SSR. I don't know what a G buffer is. Geometry buffer or what? Yes, okay. Okay. Or graphics buffer or whatever you wanna call it. Yeah, I thought so. Yeah, no one's from G. The options. Do what Doom does. Hybrid rendering. Deferred plus forward. Oh boy. Perform depth pre-pass with a small G buffer. Need at least normals and depth. Maybe roughness and nearly complete. And use the final result of the previous frame. Reprojected. Oh my god, so they save a recomputation. So they save doing it twice by reusing the frame from the previous time you drew it, and then trying to correct for view changes, I guess. Jesus. Selections will lag behind one frame. Full-blown G-buffer, so you can all later correctly manage reflection of the final output. Puts forward in the high bandwidth cost category. Right, yeah. Baggers is saying, Doom, you get into temporal AI stuff, and that is crazy town. Okay. F pre-process is the solution to everything. F pre-pause gets cheaper CPU side. Okay. I don't think that's gonna be me. F pre-pause.
Will do. P.
Thank you. Right. So the conclusion this comes to is that everything sucks. Right. Basically, the problem stays the same. Deferred has a lot of drawbacks in what you can do with it, versus forward has a lot of drawbacks in how much it costs. So what you end up usually doing is combining the two in some way to work around that stuff. Okay. Alright. So there is now different ways of doing forward shading, forward rendering that I want to look at. Right. So these are papers. They're fairly long and involved. And, yeah, I'll just be reading stuff. Can you read this, by the way, on the stream, or is it too small? I can make it bigger still. Okay, good. Make it a bit
If I maximize my browser window, then it's fine.
Okay.
I'm reading on how Doom 2016 does things, and this is so confusing.
I can imagine. Like, this is a big thing. This is, like, especially real deal engines are going to have a lot of stuff in there about how to, that, you know, makes these techniques efficient for the amount of workload they have in their games, which is not necessarily something I need to look out for right now. So I'm sure I can save up on some of these things and stuff. I just want to, you know, get a feeling about the overall techniques available and sort of see what I might want to go after. Right, so the difference between Forward and Forward Plus is that in Forward Plus you basically compute which lights are applicable for a pixel, instead of trying to go through each light in every pixel, so you can support more lights more easily. I don't think there's any fundamental difference besides that in how things are done. By the way, in case you're wondering, the soundtrack playing right now is the Assassin's Creed 2 soundtrack. It is in general very nice. Okay, so you do depth, pre-pass, light calling, and final shading. Okay. Okay, instead of calculating lighting components, light calling calculates a list of light indices overlapping a pixel. Okay. So lights can be calculated for each pixel. Better choice for final shading. Reasons is not efficient if you look at the efficiency of the entire rendering. Okay, so you do a tiling for that. Alright. Or a clustering, or a bunching, or a grouping, or whatever you want to do it. Subdivision scheme. Okay, so to do the light calling stuff with compute shaders, so that's where that dependency comes from. I see. These are complex materials. Where does pixel overdraw? And that mentioned multiple times, and I have no idea. And that may draw the same pixel more than once within a single frame, an event called overdraw. Okay. Written in 2012. Okay. By the way, does anyone know if there's a survey for OpenGL version availability? I know there's a Steam hardware review, but that only lists DirectX versions, and it doesn't include the GL versions that are available. So that's a bit of a concern. I tried searching for it a couple of times myself, but I couldn't find anything. That might just be me sucking at Google, so... $3,072 lights. Alright. Sure. I guess that's important if you want to do crazy particle effects and stuff. Okay. Alright, and then they're doing evaluation, which I don't care about. Okay, alright, so that's a relatively straightforward extension to forward. Good. Alright, so what's cluster deferred forward shading? Oh boy. Here we go! More stuff. Deferred trading removes the bandwidth bottleneck from deferred trading. Oh, so you can use... Yeah, if you have a lot of lights, you can do global illumination or sort of simulate it using that. That's interesting. Oh, so this works for both deferred and for... Okay. Oh, great. Cool. Nothing better than links that go out. Is it on way back? It is. Maybe. I only removed it recently. Indeed, the PDF. That's not the PDF. On. How old is this thing? There it is. So what I understand so far is that you...
Can you paste that Wayback link in the chat, please?
Sure. Go. So what I understand of this so far is that you turn the scene that you're looking at not into just tiles based on pixels, but clusters based on 3D information. I don't know to what end you do this, but okay. Okay. Algorithm consists of following basic steps. Which turn our scene to Jiva. First, cluster assignment. Find unique clusters. Assign lights to clusters. Shade samples. Okay. So basically, it's again a way of figuring out how to reduce the number of lights you have for each thing you want to shade. Hmm. So now they're talking about how they actually determine these clusters. Oh boy.
This feels like the 3D analog of Forward Plus.
I guess so. Yeah, it does, but I'm not sure yet. Well, like, they're doing clustering, but I don't quite know to what end yet, really. Not necessarily, anyway. What they're doing here is they're describing how to do the clustering, which is to say, because they realize, like, doing it in the world space is stupid because it needs manual tweaking. What we're going to do instead is we're going to cluster things based on the current camera view, and then they do an exponential increase in size so that things become more cubical instead of being stretched as they go farther out. And I'm guessing that they use the depth information that you have to pre-compute in the previous pass combined with vertex position to do this. Right, so they're in that. Here present two different. So I guess the benefit of this is this step, the unique clustering step, unique cluster step, because if you can figure out the minimal set of different clusters that you have in the scene, then you only need to compute some information for each type of cluster you have, sort of. Then you can apply that information for each pixel you finally shade, maybe? I don't know, that's... Whereas in the Forward Plus, you still need to do the computation for each pixel, for each light and stuff. So maybe that's the idea, I'm not sure. Unique cluster. Yeah, I don't really care about how you do this explicitly right now. My slide assignment. Brute force approach. Facial tree, oh boy. 10,000 lights. Alright. And this is... Performance analysis. Okay. I see. Interesting idea, but it seems like you need to have like a huge amount of stuff to, you know, get this going, and it seems to mostly be optimization shit. I see. That's one thing. Look at this now. Pictures. Okay. That's not interesting for me. Oh hey, list-based. Interesting. Well, well, well. All not really interesting for me. Stuff. All like PlayStation 3 stuff, I think. Didn't really apply to me at all, and hopefully also never. Shadow maps. Okay, divide screen into grid, find which license select this cell. Random quads over each cell, calculating up to 8 lights per quads. Okay, right. So they basically do this tile-based thingy. As usual, these like fucking slideshows are less than informative on how exactly they're doing things. Here's another one on like cluster shading again. I'm from Avalanche, guys. Yeah, so they're using FXAA for that stuff. I think in trial I have data. Yeah, I have an FXAA gator here. which should work. I think it's implemented. Let me see that actually. Effect. Yeah, there we go. There it is. I think you can actually... let me see if I have a quick thing I can set up. Time machine. That's not what I want. That's what I want. Let me just quickly test this. Maybe it'll work. Enter. Wait, no, that won't work. Not like that, anyway. How do I do that again? Enter. FXA plus. Next. Fucking. I have so much shit that I constantly forget how to do things. I'm gonna show this off real quick in case it still works. Next. Enter. Not how you do that though. I don't remember what I called the ports. To render pos. Render pos does what color? Yeah, okay. FXAA is a simple plus. I think this is right. I'm not entirely sure. Maybe it isn't. Who knows? It is not. Oh, it's... That should work. Crash. Yeah! Failed to link. Why? No error. Just failed to link. Whew. That's a spicy meatball. Alright, why did it fail to link though? I would like to know. Because it's not a shader compilation failure, it's a link failure, which is very interesting. Let me see that FX8 again. Weird. Should be fine. Weird. I don't know why that doesn't want to work. Yeah, that works. Strange, because I remember it working at one point, and I haven't changed anything about it, so effective shaders. I genuinely don't know. This is puzzling. Yeah. Since it doesn't really give me an error either, I have no idea. Might just be things. Oh well. Anyway. Wait, what clustered no pre-Z necessary? This says that it is necessary though. What? Huh? Actually easier to implement than full-blown tiled deferred or forward plus. Really? Okay, didn't seem like it, but it just... I'm not sure what this is supposed to be. Oh, so they're also they're not using compute traders, okay? Ability for trading. Unified lighting solution of forward pause. Okay. Whatever that means. Spatial cluster. Alright. I see. I see. So they're splitting things up because usually you have lights that are important close to you and lights that are important far away. So they're clustering things in different steps, I guess. Or something. Oh yeah, they have a like one big cluster for close things. I don't know what this means.
The blog post about Doom 2016 turned out to be really interesting and I recommend you give it a look sometime.
I would if you would link it. Oh boy. Alright.
I recommend enabling JavaScript for it. It has some nice animations for before and after effects.
I don't have it disabled. Not one of these people that disable JavaScript on principle. Interesting. Anyway, yeah, so basically all these approaches are just different ways of eliminating...
Oh yeah, that guy's articles are a great way to realize how many passes are feasible per frame when you are doing things the way the GPU likes. GTA 5 had over 5,000 passes.
Yeah, that's a lot. Right, so this and like Forward Plus both just seem like different methods of limiting the number of lights you need to compute per fragment. So far, I don't know. It's... This is weird. Like, they're talking about no force pre-Z pass, but then... how are they doing anything? Isn't it the Z information needed to build the clusters, from what I understand? Because, you know, all of this needs the Z information, right? They're even using it here at the depth. So, like what? How does this work exactly? What? I'm confused by that. I mean, essentially, you know, deferred trading is a pre-Z pass, isn't it? Or unless they're talking about something else with that. I don't know. I'm confuzzled by that. Alright, so... hold on. I wanna... look at... also, if I can find something. Focus forward 3D. No. I don't know if I can find anything in that. Oh boy. Okay, I see. So they're using a different way of calling things. By using a maximum in depth. Alright, gotcha. Okay, that's that. Thank you. So if I want to trust these guys when they say that it's easier to implement than Forward Plus, and this will probably be what I want to go for. So a deferred clustered solution, even though the fact that I don't know. So they're saying here for clustered that MSAA works fine, but they're using clustered in combination with deferred, so I don't understand how that works. Is I don't... because, you know, if you do deferred shading, then the problem is still the same in that because you render to a texture, the multi-sampling information will get lost, so I don't understand what that's about. I mean, I understand they can do clustered with forward rendering as well as they do in here, but that's not what they seem to be doing here. So I don't... Or are they like doing a clustering thing for both forward and deferred? And then finding things? I'm confused. Unified lighting solution with forward passes. Okay. Meaning what? What does that mean? Hmm. I don't know. What the fuck? reading forums is terrible as always. Anyway, so let me see. What I want to see about 4 Plus is how they do this clustering step. Or do they have source code available? Of course they don't, but let me see. Maybe they do. Probably not. Don't have anything. So hey, here's an implementation. Interesting. But that's just mean. Where's the fucking computer though? That is. Oh boy. Oh boy, indeed. I don't... Okay, let me go back to this. Why do you need to use a computator? Just so you have the things on the GPU? But what I'm wondering is whether you really need to use a computator or whether you can stuff this calculation into a standard rendering phase instead, or if that would be too bad for performance or something. Because I don't know if I want to force myself to use an API that needs computators and stuff. I mean, it'll likely be fine for most systems nowadays, but still. I don't know, it doesn't sound extremely appealing because of that. What do they use in this thingy? No, not this, actually. Is there an OpenGL thingy? Okay, so they use forward rendering first. Okay. So I'm probably gonna go through more of this stuff and actually go into, you know, the lighting and things, how to do that and implement things based on that. And then, if I feel like it, I can try to add Forward Plus, since it's pretty much just an extension to it, with some minor tweaks necessary. That seems to be my conclusione so far. And this, I think, if I understand right, the clustering approach is just a different way to do the, like, a more precise, more efficient way than Forward Plus, I guess. But at the same time, it's obviously also more complicated, probably, or at least from what I can gather from this. I don't know. Maybe it isn't. Who knows? I don't know. Oh, it even goes into PBR, nice. Yeah. Alright, I guess that's the way forward. So I'm gonna go through this stuff and implement things, maybe starting next week, actually. Who knows? I don't know. Now, I guess since we still have time, I'll read through this. This stuff. Oof, that's a bit too big. Why are these websites so fucking slow with resizing? Jesus, dick. This is extremely detailed, nice. But I also don't understand most of it, so... Okay, interesting. Right, so this is talking about what we looked at earlier, but the custom subdivision in 3D. Can you like not do the thing on your own? Thank you. Okay, so screen space reflections basically just use the previously rendered frame in order to try and fake reflections. Probably using something like, you know, seeing whether, like, trying to project the reflected thing upwards or whatever in direction of the view, or orthogonal to the direction of the view, screen view, and then seeing if the point there is included, and if not, then you copy it over or something. something. I don't know exactly, but something like that probably. Right. Right, and then they're doing the cube map thingy that I explained earlier. So basically what they do here is they pre-compute several cube maps that render the scene at that position, which are then used to do the reflection lookups. Probably guesstimating the closest one based on position in world space. Oh, it even fucking blends between them, okay. Right. Okay. Right, interesting stuff. But yeah, that's gonna be next doing all of this stuff. Hooray! Well, I imagine that this was a pretty boring episode, or whatever. I'll try to remember to put the things I read into the description of the video, so that people who aren't live can also watch it, read it. So if you aren't live, then... What are you doing? What is wrong with you? Anyway.
It was chill, thanks for the links.
Sure, was interesting. Right, so next time... Math. Probably. Or actual rendering stuff, and actual implementation stuff. Hooray! Yeah, thanks for stopping by.